In today's lesson, we're going to learn about equations of circles. First and foremost, we're going to start off with the standard form of the equation of a circle. That is the following: x minus h squared plus y minus k squared equals r squared. When we write this equation, which will work for any circle, we're always looking to fill in these three letters. The first two are hk, which is the center point. H is the x value of the center point, and k is the y value of the center point. The last letter we're looking to fill in based on our circle given is going to be the radius, which is r. Remember, the radius is always the distance or length from the center of our circle, that center point, to any point on the outside of our circle. Today we are going to look into 4 different cases for writing an equation of a circle. The first case is I will have a problem giving me the center and the radius or diameter, like so. For example number 1, I have the center of -1, 7 and the radius of 14. So remember, we always want to plug in h, k, and r. I'm going to show you with colors where I'm getting these letters and plugins from. So -1 in yellow is my h value. That is going to be the x value of my center point here, -1. K is going to be the y value of my center. I'll put it in pink. That is going to be 7. Plug it in here for my standard form where k belongs. Last but not least, my radius will be green. My radius is 14. I plug it in here over on the right side of my equation. Radius squared, which is 14 squared in this case, which is where I got the 196. Last but not least, I want to fix this negative sign over here. It reads x minus a -1, and I want to change that negative to a positive. Clean that up. So my final equation is the quantity x plus 1 squared plus the quantity y minus 7 squared equals 196. For problem number 2, I have the same kind of concept. Center is 0, 9, and the diameter, not the radius, is 32. So first and foremost, I need the radius. That's what the standard form requires. So I split that diameter in half. 32 divided by 2 gives me 16 as my radius. I go ahead and plug this in my equation. I'm always replacing h, k, and r. Here we go. X squared plus quantity y minus 9 squared equals 256 in the end. Last example here for this case, I'm given the center 15, -6, and the radius, which is the square root of 158. The square root might intimidate you, but it actually is going to work out nice in the end. So I'm going to use my colors again to help us out. Here we go. My h in this problem is the x value of my center, which is 15 in this case. So 15 plugs in for where h belongs in the standard form. My k is going to be -6. It's the y value of my center. I plug that into the standard form where k belongs. Last but not least, my r value is the square root of 158. I plug that in and make sure to square it because it's not just r, it's equal to r squared. What happens when I square the square root of 158 is it actually cancels out the radical. I can write this in the end as just a plain 158. That's what happens when I have a square root and I square that radical number. So this will come out to be equal to just plain 158. So my equation reads the quantity x minus 15 squared plus the quantity y plus 6 squared equals 158. For case number 2, let's go ahead and look at that one. I'm going to be given a graph. So here I'm given a graph of a circle, and I need to find that equation. So first and foremost, I want to look at my center. The center is the middle point right here. Well, that's easily at 1, -3. My radius, how I find that is it's always the length from the center point to any point on the outside of my circle. So I'll go directly horizontally. It's easy to count this way because I can count 1 space, 2 space. That's how I get my radius of 2. I go ahead and plug it in my equation as so. Here's what I get. The quantity x minus 1 squared plus the quantity y plus 3 squared equals 4. Now we're going to look at case number 3, where we have to write an equation of a circle given the center and a point on the circle. You'll notice in these two examples that we do not have the radius right away, we'll have to solve for it, but that's easy enough because the radius is just the length or distance between the center of the circle to any point on the circle. So all I have to do here is use distance, the distance formula, to find the radius between these 2 points. Here we go. For example number 5, I had the center as 9, 10, which is h, k respectively. And then I have a point on the circle -6, -10. Any point can be labeled as an x, y value. So we're going to go ahead and find the radius, the distance between these 2 points. So I'm going to do this on Desmos. You could use the distance formula if you choose to as well. But go ahead, if you need a second, take out your Chromebook or your phone to go ahead and pull up Desmos to help us with this distance. So I plug in distance, my point in the center of the circle, and the point that lies on the circle. That distance between them is 25. That is indeed my radius for this problem. So I go ahead and label everything I know. I know the x value of my center is 9. I know the y value is 10. And I also know my radius is 25. So I have h, k, and r, my 3 letters to go ahead and plug in my standard form of this equation. The quantity x minus 9 squared plus the quantity y minus 10 squared equals 625. Let's go ahead and do another example to help us out. Here we go. In this problem number 6, I'm giving the center as 1, -5, h, k, and my point on the circle is -6, -13, x, y. So I'm going to go ahead and not use Desmos for this one, just to show you yet another way to solve this. Here we go. I take my standard form of our equation of a circle. Here's what it is. We've been using it all along. I'm going to go ahead and use colors to help us out because I want to plug in what I have. So I am given h as 1. I can plug it into h in my standard form of our equation. I'm also given k as -5. I can plug that in for k in our standard form. I also have -7 as x. I can go ahead and plug that in for x. And then I have y as -13. I can actually plug that in for where our y is in our standard form. That's going to look a little bit like this with some numbers instead of colors. Let's take a look. Here we go. So I go ahead, I have everything equal to r squared. Well, super easy. I want to get r squared. I want to get the radius, so I just go ahead and solve that left side. -7 minus 1 squared equals 64, because I get -8 and square it to get 64. Same thing over here, -13 plus 5 gives me -8, squared gets me 64. Super easy, 64 plus this 64 gets me 128. Now, if I wanted just the radius, I would take the square root of this, but I can actually just plug this in our standard form of our equation, 128 here, because it's saying it's equal to r squared, and r squared is that 128. So no need to square root there. Super easy. Just plug it on in. Here's our equation. The quantity x minus 1 squared plus the quantity y plus 5 squared equals that 128. Now we're going to look at our last case, case number 4, where we have to write the equation of a circle given 2 endpoints of a diameter. So we are really missing those 3 key letters, our center, h, k, and the radius. But luckily, like last time, like the last 2 problems, we can find the radius by finding and using the distance formula. So you can either do that by hand or on Desmos like we did. The second thing we have to do to find the center is use the midpoint formula. Why do we use the midpoint formula? Well, we think about that we have 2 points on opposite ends of that diameter. So to find the middle of our circle, the center, the exact center, we think about middle and about our midpoint in this case. So let's go ahead and do example number 7. We're given 2 points on a circle here. The 2 points are as follows. We have 6, -2, which is our x1 and our y1. And over here we have our second point, -2, 4, x2 and y2. So the first thing I'm going to do is find the diameter. They're the endpoints of a diameter, the points on a circle. So when I find the distance between these 2, it will give me my diameter. So let's go ahead, look at Desmos. Again, if you need a second to pause this video to pull it up, go ahead. But here we go. Type in distance, our first endpoint and our second endpoint. It gives us the distance is 10. So when I go back to my worksheet, my problem, notice how I then divide it by 2 to get my radius, because that is the length of the diameter, not the length from the center to the edge, but the length from one edge to the other edge. So I have to divide it by 2 to get that radius. The next thing, like we said, we need to solve for is the center, that HK. So I'm going to find the midpoint of my diameter. That will be the exact middle of my circle. So I go ahead back to Desmos. I do the same points, but with the midpoint formula now. And I get on my graph and labeled here 2, 1. That is going to be the exact midpoint of my circle. Going back to my problem, that's going to be my HK here. We have everything to plug it on in our standard form of an equation. H is going to be this 2, K is going to be 1, and our R was 5 squared to be 25. So our equation comes out to be the quantity x minus 2 squared plus the quantity y minus 1 squared equals 25. Alrighty, so last thing we're going to look at is we're going to work backwards. So we're going to go ahead and work backwards, say that we are given the equation of a circle and we need to identify the center and the radius or diameter of that circle. So here we go. First problem here, number 8, I'm given the standard form of my equation of this circle. We know that h is in this place, it would be 5 in this case, a positive 5. K is in this placement, which would be a 1. That's making up my center, that 0.5, 1. This 64 is really saying what r squared is. So in order to find just r, just the radius, I got to undo that squared by taking this square root. Well, the square root of 64 is 8. That's the radius. We want the diameter. So I just multiply that radius by 2 to get me 16 here. So again, same thing here. I have the equation working backwards. I need the center and the radius. Here we go. This 6 is going to be a positive 6 for my center, my h. This positive 11 is really saying it's a negative 11, because remember, like in that first example, we had a negative negative, which made it positive. Pulling it back out would be a negative in this case. Last but not least, 58 is what r squared actually is. So again, to undo that r squared to just get the radius, not the radius squared, but just the radius, I have to square root the 58 as my answer here. You cannot simplify this down by factor treeing it. It's the simplest radical, so you are all good. So that's our lesson for today. Thanks for watching.